Okay, so about polar coordinates, we are having around 4 main topics. Okay, so first, change polar to the rectangular, right? And vice versa. So this one will be r and theta, and this one will be x and y. Okay, we want to change between these two coordinates. The second one, okay, will be the symmetry in polar coordinates. Okay, the third part will be about some useful graph. Okay, the graph that you will see on the exam and the last one will be the integral in polar. Okay, we have 4 main topics. Okay, so let's start. I will not go into the details that much, okay, because I think you already learned in class already. Okay, so first start to change from polar coordinates to the rectangular coordinates. Okay, so when I review the rectangular, okay, or I'm not sure that your lecturer using the rectangular coordinates, or they call it the Cartesian coordinate. Okay, it's the same, right? It's just the xy like this, right? And when you want to indicate any point in this plane, then you see that how much they go in x direction and in y direction. Okay, so you get the coordinate x and y like this. Okay, this is how you do in the rectangular coordinates. When we want to change it to polar coordinates, right? We have what it called the polar axis. Okay, here I call the pole axis. Okay, in polar. Then, if you want to indicate the same point here, right? Instead of how much you go in x and y direction, you see what is the length of this arrow. Okay, the length here, we call it r, or the radius. Okay, let me change a little bit. Okay, and another thing that you need to know is what is the angle, okay, between the polar axis and that arrow. So it's here. Okay, the angle is theta, like this. Okay, so you get the coordinates r and theta like this. Okay, this one is the polar. This one is the okay. You can see that these two ways of giving the coordinates give you the same point, but into different approach. Okay, so how we going to change from the rectangular coordinates to the polar coordinates, right? To polar. Okay, if we want to change from rectangular coordinates to polar, then we have x and y, right? This is what we have. We want r and theta. We get r from the Pythagoras theorem. Okay, as you can see here. If you want r, then we can using the Pythagoras theorem. So it will become the square root of x squared plus y squared. Okay, and the theta will be arctan of y over x. Okay. Okay, so this is how you change from the rectangular coordinate to polar coordinate. Okay, but it's not all, because as you can see from here, this is one way to represent the polar coordinates, right? I will just use the same picture. Okay, and by using what I already tell you, right? Then you can see that this is one way in giving you this point in polar, right? R and theta like this, but I can use the same R here. Okay, and instead of I'm going in this direction, right? I can go in this direction too, right? So this also can be my theta. Okay, or even weirder, I can have like the another line here. Okay, so this one will be minus r, and then I go until here, right? I also can get to that point. This is another theta. So as you can see that the rectangular coordinates, when we change to polar coordinates, the polar coordinates doesn't have the properties, the uniqueness properties, okay? No. Okay, no uniqueness properties. So if you already, this one, okay, the r and theta that you get from this formula, you will get the uh, the I will call it the main one. Okay, so you have r and theta, right? Then you can get the family of this point. Okay, so there will be r at theta plus 2n pi. Okay, n will be the integer. Okay, or you can have the minus r. Okay, theta plus 2n plus 1 pi. Okay, this also the family of this point. Okay, n is the integer. Okay, so when they ask you to change from rectangular coordinates to polar coordinates, if when you putting this equation, right, you will get the main one. If it's not in the answer, right, in the multiple choice, then try to add this. Okay, and one of them will be in the multiple choice. Okay, this is how you change from rectangular to polar coordinates. Next is when you want to change from polar, okay, to the rectangular coordinate. This one is easier because you have r and theta, right? You want to change it to x and y. X is equal to r cos theta, and y is equal to r sin theta. Okay, and in the rectangular coordinates, xy is unique, so it has the uniqueness properties. So there will only be x and y. Okay, this is how you do to change from polar coordinates to the rectangular coordinates. Okay, so let's try. Okay, let's practice a little bit. Okay, okay, so okay, so I give you like 5 minutes. Okay, and try to answer this yourself. Okay, the left one will you need to change from polar coordinates to the rectangular coordinate. So this one will be r, and this one will be theta, and this x and y. Okay. If you understand this part, then for other parts we will going faster. Okay. Okay, so I hope you try to do it yourself. Okay, so if you want to change from the polar to rectangular, right, then x will be 2 cos of, I'm sorry for this one. Okay, for the polar one, I didn't give you the angle. I just calculate myself. Okay, sorry for that. Okay, but you can just write it like this. Y will be 2 sine. Okay, because at first I try to give you the nice angle. I already calculated that. I write it. Okay, and another one will be x equal to cos of minus 3/2, like this. Okay, in the exam there will be the nice radius. Okay, more than this one. And for the rectangular to polar coordinates, right, then I want r is equal to square root of 4 square plus 3 square, which is 5 square, which is 5, and theta will be the tan inverse, right, of 3/4. Okay, and for the another one, this thing will have a bit of problem if you using this definition. As you can see that this one will be 0 square plus 5 square, which gives you 5. But when you put in this definition, you will get 5/0, right? And this is a big problem because you can't divide by 0. Okay, so if you have x equal to 0, okay, if x equal to 0, then it will be in the vertical axis, like this one. Okay, and you can see that if it's 5, 0 is over here, right? So this thing will be pi/2. Okay, okay, so it's pi/2 if y is greater than 0. Okay, y is greater than 0 and x is equal to 0. And if y is less than 0 and x equal to 0, this thing gives you minus pi/2 or 3 pi/2. Okay, so this is like some special case. Okay, okay, so this is how you change from polar coordinates to the rectangular coordinates and vice versa. In points, right? This one I give you points and you need to give me another point in another coordinate. Next is the similar ways. Okay, now we want to focus on the equation. Okay, we want to change the equation from the xy to r theta. You're using the same properties. X equal to r cos theta, y equal to r sin theta. Okay, and r is equal to square root of x squared plus y squared, and theta equal to arctan of y/x. Okay, you use this one, and then you can change the equation. right? So if they give you like x, y plus 4 equal to 0, like this one, and they want you to change to r and theta, right? Then you just x equal to r cos theta, y equal to r sine theta, plus 4 equal to 0, and that's it. Just this one. Okay, but sometimes you need to know some properties of trigonometric function. Okay, because like this one, right? I get r square and cos theta sine theta, like this one. And if you know the properties of this, right? The properties of trigonometric function, you can see that this thing, right, is almost the you almost get the properties already, right? Okay, so this thing you if you use sine of 2 theta is equal to 2 sine theta cos theta, right? If you use this one, then this thing plus 4, right, can become square, and this one will become sine of 2 theta over 2 plus 4 equal to 0, like this. Okay, since you're doing a multiple choice, right, you sometimes you need to use some properties to change and see that which one is match the multiple choice. Okay, there is this sine 2 theta, and there also like cos 2 theta. You can find it on the internet. Okay, and many more, like sine of a plus b, like that, cos a plus b. Okay, and many more trick properties. Okay, hope you're going to review. Okay, so this is how you do for the trick changing from rectangular to polar. You can change in another ways also. Okay, if you have like equal to 3 plus let me think. R equal to 1 over 3 cos theta, like this one, right? Then actually you can just do it straightforward. Okay, like it's become x squared plus y squared equal to 1 over 3 cos of, okay, if you do like this, it's theoretically correct. Okay, but most of the time you don't see this type of equation in the multiple choice. Okay, so you need to do something, right? This thing you can multiply by 3 cos theta both sides, right? You get 3 cos theta equal to 1, right? And our cos theta here is x. See? So this thing will be 3x equal to 1. Something like this. Okay? So you can get something like this one. Okay, so hope you can do the changing the equation. Okay, I think this one is easier, it's more straightforward. Okay, because when you're doing the points, right, they can be tricky because they change it and then they add on minus some pi, some 2 pi like that, and you don't see your answer straightforward. But this one, if you do it properly, then I think you won't get any mistake. Okay, hopefully. Okay, so for the next part, this part, do you have any question? If you have any question, you can ask me. Okay. Okay. So the next thing I want to tell you about is the polar. Okay, the symmetric in polar coordinate. Okay, in the rectangular coordinates, I think you already familiar with like odd function and even function, right? This thing is the symmetry already, but this one they also have symmetry, but in different way. Okay, the symmetry, they have 3 symmetry. One is symmetric to pole. About the pole. Okay, the about the polar axis, and the last one is okay, the polar axis pole, and then the vertical axis. So as you can see, right, this one we call it the polar axis, right? This one vertical. Okay, and the pole is over here, the origin. Okay, so how we going to find? So if it symmetric to the pole, then theta will equal to r. Okay, it will symmetric to the pole. In another case, if it symmetric to the polar axis, it will be r theta equal to r minus theta. And the last one is r theta is equal to r pi minus theta, like this one. Okay. So this is the symmetry. Okay, and let me see. If you have the equation, okay, this one, as you can see, it's for the point. If you have an equation, usually equation, right? Equation, if it is in the rectangular, right? We usually like write y equals some fx, right? Okay, y will be on one side and x will be on another side. If it in this form, right? In polar, we also have something like this, polar. Okay, we usually write r equal to some f of theta. Okay, and the symmetry we can check when it is the equation also. So let me erase this one. Okay, so if it's about the pole, then equal to f theta, right? It will be equal to when we replace with minus r equal to f theta. Okay, and also r equal to f of pi plus theta. Okay. Okay. Next one is symmetric about the pole. If it about the polar axis, okay, equal to f theta, right? It will be r equal to f of minus theta. Okay, and the last one r equal to f theta. Right, you can change theta to f of pi minus theta. Okay, if these two are equal to each other, then it means it's symmetric. Okay, polar axis and vertical. Okay, so let's see some example. Like if I get r equal to 2 minus 2 cos theta, like this one. Okay, is it symmetry to polar axis or the vertical axis, or none of them, right? So first I check at the pole first. So this one, right? If I change r to minus r, I get this one equal to 2 minus 2 cos theta, which is r equal to minus 2 plus 2 cos theta. And it's not equal, right? So if it's not equal to the original equation, then it's not symmetry to the pole. And another one, right? I want to check that it's symmetric about the polar axis or not. So I change theta to minus theta. I get 2 minus 2 cos of minus theta, like this one. And the cos function, right, is even function. So this thing will become cos theta. Cos of minus theta is equal to cos theta. So as you can see that these two is equal to each other, so it's symmetric about the polar axis. Okay, and check another one. R equal to 2 minus 2 cos of pi minus theta, right? Is it equal? The answer is no. Okay, because pi minus theta and theta cos of pi minus theta and cos theta is not the same. Okay, so this thing is not also not symmetric to the vertical axis or vertical line. Okay, this is how you do the symmetric. Do you have any question? Okay, if you don't have any question, I will go to the graph. Okay, because I want to mainly focus on the integral. Okay, because the integration you can use in the double and the triple integral also. Okay, so if you don't have any question here, then I will ask. Okay, so for the graph, I will focus on like mainly 3 graphs. Okay, there are many more graphs. Okay, you can go and study yourself. Okay, but the graph that I'm going to focus is one is the circle. Okay, the second one is called the cardioid, and the third one is called the limaçon. Okay, this 3 graph, I think is the graph that you're going to see most of the time. There are another graph like the rose graph, the spiral graph, and many more. Okay, you can go and study yourself. So for the graph, right, let's start with the circle. Okay, the circle you can have r equal to a, right? Like this one, r is equal to a. So the graph will be like this. It's a circle like this, and the radius here is a. Okay, and you have another type of circle like r equal to a sine theta. Okay, and also r equal to a cos theta, like this one. Okay, these 3 will give you the circle. Okay, but different type of circle. Okay, so this one will be like this, and this one will be like this. Okay, and what is the most important thing is that when r is equal to a, right? The radius is a, but when r is equal to a sine theta, the diameter here is a. Okay, so the radius is just a over 2. This also, the diameter is a. Okay, this is very important. Okay, many students have this mistake. Okay, and if a is negative, then it's going to go downstairs. Okay, if a is negative, then it's going to be here. Okay, okay, a is negative. Okay, the next one that we're going to talk about is called the cardioid. Okay, the cardioid is the heart shape. So it's r equal to a plus a cos theta and r equal to a plus a sin theta. Okay. Okay, and the graph will be like this. If it is a plus a cos theta, right, it become this one. Okay, something like this. And if it is a plus a sine theta, then it will become something like this. Okay, and here is a, and here is 2a. Okay, and if it is minus here, if it is minus, then it's going to flip. Okay, it's going to be like this. Okay, and this is also going to be like this, something like that. Okay, if it is minus, then it's going to flip to another side. Okay, this is called the cardioid. Okay, and the last one is called the Limassol graph. The Limassol, there are two types. Limassol is in r equal to a plus or minus, and r equal to okay, there are there will be like this one. Okay, they have two types. Let me just draw first. They are calling the dim lemma song and the just lemma song. Okay. So it will be like this one. Something like this. Okay. And for sine is also the same. Okay. Like this. And another one is going to be like this. Sorry. Like this. Okay. And this one is going to be like this. Okay. And this two different is that if A over B, okay, is less than 1, then you get this one. And if A over B is greater than 1, you will get this one. Okay. Sometimes they split this type into two parts, right? Sometimes I'm not sure that your professor using this one and A over B greater than 2, like this or not. Okay. But you get kind of similar graph. This one you will get like this, like what I already drawn, like this. And this one you get something like this. Okay. Okay. And this one is all for A plus B cos theta. Okay. If it is minus, then you flip. Okay. If it is sine, it's up and down. Okay. If it cos, then it's left and right. Okay. So do you have any question about this one? And you need to know something about the point on the graph, because when you want to do the integral, then you need to know where you will integrate from theta equal to pi to 3 pi over 2, something like that. Okay. We will talk about it when integration later. Okay. มีคำถามอะไรไหมครับ Okay. So if you don't have any question, then I'll go to the integration. Okay.
So, are those cardioid and limaconic are included in parabola graph?
In what do you say?
Parabola.
Parabola, right?
Yes.
No, it's not type of parabola.
So, parabola graph is like separately from these.
You say the parabola, like this one?
Yes.
No. It's this one is like y equals to x square, something like that. The parabola. Or you mean the polar graph? If this one is the polar, the graph in polar coordinates. You can say it is polar graph.
Okay.
Okay. Actually, there are more than this one. You can get line by using the polar also. You can have several graph, right? Like the spiral or the rose graph. But usually you not see in the exam. But if you want to study more about this type of graph, then I think it's good for you, right? And actually, if you can see that the cardioid, right, is a type of limaçon, right? When A and B is equal to each other, or I can say A over B is equal to 1. Okay. So let's go to the integration in T of polar. Okay. I will not going through the how you get the integration. Okay. You can go study yourself. Okay. This tutorial, so I will just review, right? When you want to do the integration, right? When you want to find the area, then by using the polar coordinates, then you get 1/2 integration from alpha to beta of f theta square d theta. Okay, you get this one. Okay, and if you want to find the area between the curve, then you just minus. Okay. Okay, so between the curve, right, is a equal to 1/2 of fx f theta square minus g theta square d theta. Okay, like this one. Okay, let me find some example. When you want to do the integration, let's just doing the some easy one first. So I will just doing the cardioid. Three plus three cos theta. Okay, like this one. Okay, if it's just the area, then it's not that difficult. Okay, so if I want to find the area of this one, right, then A will equal to 1/2 integral from 0 to 2 pi, okay, of 3 plus 3 cos theta square d theta, like this. Okay, and you can calculate it. 2 pi, this thing will be 9 plus plus 9 cos d theta, like that. And then you do the integration, right? This thing will be 9 theta plus integrate cos will be sine, right? Plus the cos square. I need to do the cos of 2 theta equal to cos square theta minus 1. So cos square equal to plus 1/2. Okay, I change this one first. Okay, because this it's easier to integrate. So this thing will left with 2 pi of 9 cos 9/2 theta plus 1. Okay, and this one will be 18 pi plus sine of 2 pi is 0, right? Sine of 0 is also 0, so get this one. This thing will be cos will be sine over 2 plus theta. Okay, and this thing will be 9 pi plus 9 over 8, and when I get 0 for this one, and for another one I get 2 pi, so get 9/2 pi. Yes. Okay, so it's going to be 27/2 pi, something like this. Okay, hope I'm doing the integration correctly. Okay, this is how you do the integration, okay, for the polar coordinate. Okay, if somehow they give you that the find area between some curve, that's going to be a bit more difficult. Let me find some example for you. Oh, okay. Let's try this one. Okay, find area outside the cardioid equal to 2 plus 2 sine theta, and inside the circle r equal to 6 sine theta. Like this one, it's going to be a little bit harder, right? First thing you need to do is draw the graph. Okay, r equal to 6 sine theta. Okay, this one we're going to be like this. Okay, and at here is going to be 6. Okay, this one is r equal to 6 sine theta. For another one, r equal to 2 plus 2 sine theta, right? It's going to be at 4. Okay, here's going to be 2 and 2 like this. So it's going to be like this, something like this one. Okay, and it said that outside cardioid, inside the circle. So it's going to be over here. This is area that we want. Okay, how are we going to do it? What we need to do is, first we need to find these 2 points, the intersection point. Okay, these 2 intersection point. So we let these 2 equations equal to each other. Get 2 plus 2 sine theta equal to 6 sine theta, like this one. Okay, we get 4 sine theta equal to 2. Okay, and sine theta equal to a half. Okay, we get the theta equal to pi over 6 and 5 pi over 6. Okay, and this is 2 points that we want already. Okay, but as you can see from here, it's not every intersection point. You can see that here is also the intersection point, right? It's meet at that point also, but by using these properties, you can't get another point. Okay, but in this case, it's good enough already because we get 2 points that we want. Okay, now let's do the integration. right? So the area will be 1/2 integral from pi over 6 to 5 pi over 6. Okay, because here is pi over 6, here is 5 pi over 6. We want to integrate from here to here. Okay, and the upper one will be 6 sine theta square, okay, minus 2 plus 2 sine theta square. Okay, d theta. Okay, and you do the calculation. Okay, so I just do 5 pi over 6, and this thing will be 36 sine square, right? Minus this thing will be 4 plus 8 sine theta plus 4 sine square theta d theta. Okay, like this. And then you do the calculation. When you have sine square and cos square using this one, okay, using this property, cos 2 theta equal to cos plus sine square theta minus, sorry, equal to 2 cos minus 1 equal to 1 minus 2 sine. Okay, you're using these properties. Okay, you're going to use this property a lot when doing this integration, okay, in polar. Okay, and you can do the integration yourself. Okay, do you have any question about this part? This is all about the polar coordinates. Okay, do you have any question? If you don't have, we have like 10 minutes. Maybe I will just intro about the double integral. Okay, okay, so I think you don't have any question. Then let's go to the multiple. Right, the multiple integration. Maybe I just tell you what will be in the multiple integration, and then you can go and review yourself first, and next time if you have any problem, then we can have some discussion. Okay, so there will be double, right, integration. Okay, in the double integration, I think that what you're going to see is finding the area, something like that, right? And one thing that you need to know is integration. Okay, you evaluate or you're doing the integration. Switching the order of integration. Okay, this is what you're going to see in the double integral. The substitution, okay, the substitution, and in this they will have the Jacobian determinant, okay, the Jacobian. Okay, the one of the substitution that mostly used will be the polar. Okay, the polar substitution. And I think the double integral is just this. For the triple, right? The triple integration, I think is, and switching a little bit, right? The substitution, okay? The Jacobian already have, right? And the one that you're going to see the substitution will be cylindrical. The cylindrical and spherical. Okay, I think this is two of the one that you're going to see. The abstract one, I think you don't going to see it. Okay, just this two. Let me check. Yeah. Okay, there will be all of this, but what is important is how you're switching the integration and how to do the substitution. Okay, this is what I'm going to focus on. Okay, because the integration, you use technique from the integration from calculus 1. Okay, and but what you never see is the switching the order of integration and substitution. Okay, so hope you revise it first, and then we have some discussion next time.